You know that office phone on your desk? Or maybe the security camera you see up on the ceiling? Ever notice how they often have just one single cable plugged into the back, and that's it? Yet they work perfectly. It's not magic, but man, it's close. We're talking about this incredible hidden technology that powers our world, and today we're going to unpack the genius behind Power over Ethernet. So let's just picture this for a second. On the left, that's the old way, the messy way. You had a power cable and you had a data cable, two separate things to manage for every single device. But on the right, that's the elegant solution. One single Ethernet cable doing both jobs at once. And that simple change, it completely revolutionized how we set up our networks. So the big question is, how? How in the world does one little cable do two totally different jobs at the same time? Without the data getting all messed up or the power just frying the connection? Well, to get that, we need to know what we're actually talking about. Okay, so Power over Ethernet, or PoE for short, is basically a standard that lets us send low-voltage power over the same cable that's carrying our data. Now, a standard Ethernet cable has 8 little wires inside, but for a long time, networks only used 4 of them for data. So the early simple solution was to just send power over the 4 wires that weren't being used. Easy enough, right? But modern systems are way smarter. They use something called phantom power to send electricity over the exact same wires as the data, but in a way that the two signals don't even know the other one is there. It's just incredibly clever. The whole system is beautifully simple, really. It just comes down to 2 key players. First, you've got the power sourcing equipment, or PSC. Just think of this as the source, right? It's usually a network switch, and its job is to send power out. Then, on the other end, you have the powered device, or PD. That's your IP phone, your security camera, whatever it is that's designed to take in that power and use it. Okay, so it's a really neat trick. But you might be wondering, why? Why go through all this trouble just to get rid of one cable? Well, the answer gets at this brilliant and maybe kind of surprising philosophy that's at the heart of all great engineering. And this quote from NetworkChuck it nails it. Any good IT engineer is really lazy. Now, hold on, in this world, lazy is the best compliment you can get. It's not about being unproductive. It's about being efficient, avoiding pointless work, and always, always finding the simplest, most elegant solution to a problem. And this is exactly what that lazy efficiency looks like in the real world. Think about it. If you wanted to install a security camera on a high ceiling, you used to need a network guy to run the data cable, and you needed to hire an electrician to install a whole new power outlet up there. That's 2 different people, 2 bills, and a huge pain. With PoE, the network engineer just runs 1 cable. That's it. You can put your devices exactly where they need to go, not just where there happens to be a plug. It's cheaper, it's way faster, and it's infinitely more flexible. But the story of PoE didn't just stop with powering a simple desk phone. Oh no. Once engineers got a taste of what was possible, it kicked off this incredible quest for more and more power. And you can see that whole journey right here. It all started back in 2000 with a Cisco system that gave you about 7 watts, just enough for a basic phone. But then, the official standards bodies got involved and things really took off. The first official PoE standard in 2003 gave us 15.4 watts. Then, by 2009, PoE Plus doubled that to 30 watts. And then came these huge leaps, 60 watts, and finally, in 2018, we hit a massive 90 watts of power from one little Ethernet port. Every single step unlocked bigger, better, more power-hungry devices. So here's a quick cheat sheet for you. We just categorize them by type. Type 1 is your basic PoE, Type 2 is called PoE+, and then Types 3 and 4 are both under the PoE++ umbrella, giving you that 60 and 90 watts. Now, the absolutely crucial thing to know here is that they're all backwards compatible. So a brand new high-power switch can safely power an old low-power device without any problems, which is a total lifesaver. But hold on, pushing all this power down a data cable, that sounds a little risky, right? I mean, what happens if you accidentally plug a device that doesn't need power, like your laptop, into one of these ports? Well, this brings us to the really important difference between smart power and dumb power. The vast majority of modern stuff uses what we call active PoE. This is the smart system. Before it sends any real power, the switch and the device have a little chat to figure out exactly what's needed. But there's this other, older way called passive PoE, and it's dumb. It just blasts a constant voltage down the cable 24/7, whether the thing on the other end wants it or not. This digital handshake is the secret sauce. It happens through negotiation protocols. You'll mainly hear about CDP from Cisco and LLDP, which is the industry standard. It works like this. When you plug in a device, the switch sends out this tiny, totally safe, low-power signal. If the device on the other end is a PoE device, it answers back and says, hey, yep, I'm one of you and I need this much power. And only then, after they agree, does the switch send the full voltage. It's this smart agreement that makes active PoE so safe. And this is exactly why that negotiation is so important. With passive PoE, that power is always on. So if you accidentally plug your expensive laptop into a port that's just blasting out 24 volts of passive power, poof, you can instantly and permanently fry its network card. Active PoE is designed specifically to prevent that from ever happening. So when you combine this smart, safe power delivery with that ever-increasing wattage, wow, the doors just fly open to some truly exciting possibilities that go way beyond just phones and cameras. Which brings us to this number, 90 watts. Just let that sink in for a second. 90 watts of power delivered over the same thin cable that's carrying your internet traffic. That's not just a small convenience anymore. That's enough power to actually change how we wire our buildings. So I have to ask you, what do you think you can run with 90 watts of power? The answers are probably a lot more surprising than you think. We are talking about some serious hardware now. With 90 watts, you can power those high-performance security cameras that pan, tilt, and zoom. You can power other, smaller network switches. You can even power laptops with a simple adapter. We're seeing entire office buildings wire up their LED lighting systems using nothing but PoE. And get this, even components of HVAC systems can run off an Ethernet cable now. It's incredible. So the next time you see a device with just one cable plugged in, you'll know the secret. It's all thanks to some brilliant, lazy engineering and a constant quest for more power. And it leaves us with a pretty fascinating thought. What happens when the line between the power grid and our data network just completely blurs away?